Alright, ladies and gentlemen, today we are going to define and use zero and negative exponents. So we're going to see what happens to our bases if we raise them to a zero power or even a negative exponent. Alright, so let's look at the definition of zero and negative exponents. We have three different situations that we can talk about. The first one is if a to the zero power, when we raise a base to anything to the zero, it becomes 1. Okay, so in algebra, so we have variables here just to represent, because you have situations where you just deal with letters. A to the 0, okay, is just going to give us 1. So if we have a number, for example, 5 to the 0 power, well, that's being raised to the 0, so we have just 1. Okay. Alright, so the second situation, a to the negative n, is the reciprocal of a to the n. So in other words, if we are raising our base to a negative exponent, well, remember, every power that we have is written over 1. Okay, so then if we want to rewrite this power with a positive n, well, we've learned that we can move this numerator down to the denominator and then the sign of the exponent changes. So now I would have 1 over a to the positive n. So if I'm dealing with a number 2 to the negative 1, okay, that 2 to the negative 1 is still over 1, and then I'm going to rewrite it with a positive exponent, so I'm going to bring the 2 to the negative 1 down. So I'll have 1 over 2 to the positive 1, which is still 1/2. Okay? And just to show you the flip side of that, a to the n, so if we raise our base a to a positive n, that is the reciprocal of a to the negative n. So it's kind of like this, the same situation as we have up here. It's just showing you that, well, if we raise the nth power, we can still write that over 1, and if we want our expression to be written with a negative exponent, we can bring that down to the numerator, and the sign of the exponent changes. So we have 1 over a to the negative n. So with the 2, which is 2 over 1, that can be written as 1 over 2 to the negative 1. When applying these rules, and especially the exponent rules dealing with division and quotients, it's very important that you do still keep in mind that there's a numerator and a denominator in every single expression.